Lesson 7-4 is using the Pythagorean theorem to find the distance between 2 points. And the important thing here is if your points are exactly vertical of each other or exactly horizontal of each other, you can just count how many units or how many blocks on your graph they are apart. So finding distance is easy. So just for an example, if I asked you to find the distance between this point and this point, that's pretty easy, right? From 2 to 6 is 4. So we know the distance of that length is 4. If I ask you to tell me the distance of between here and here, again, pretty easy. We go from 3 to 8, that's 5, or it's 5 blocks long. That's easy. But when you have a diagonal, and we know that's now the hypotenuse, you can't just count the blocks. And don't put this on this graph. We're going to use this graph for something else here in a second. We can't just count the blocks, right? So we can't just easily say it's so many units long because it's a diagonal. So if your points are horizontally on top of each other or vertically side by side, distance is easy. When they are diagonal from each other, that's where you have to use the Pythagorean theorem. All right, so this little explore it, we're not gonna really work much through it. I'm just gonna show you how to put this information on a coordinate plane. It says, how could you represent the starred locations on a coordinate plane? Well, let's look at the 2 starred locations. We have the castle and we have the clown house. And all that wants you to do is, if you think of this, it's gridded. So you could easily think of this as a y-axis and an x-axis, right? There's your there's your x-axis. And this is your y-axis. And the castle is right here. So on the coordinate plane, that's at 1, 3. So on the coordinate plane at 1, 3, you could put a point and that would represent the castle. And I'll just draw a little castle here. There you go. There's my castle. It's beautiful, isn't it? And then same thing for the clown house. Okay. If we wanted to put the clown house on a graph, well, it's at 1, 2, 3. This is 4 up 1. So it's at 4, 1. And there's our clown house. So that's what it means by putting the starred location on a coordinate plane. It just means making the little graph a coordinate plane. Yes. Yes. And just like I said a second ago, okay, if I was to ask you the distance between the castle and the clown house, well, the problem is they're not right on top of each other or right side by side. They're diagonal from each other. So I can't just count how many squares it is. So you have to make a right triangle out of it. And you do that by adding a leg and a leg. And now, based on what you know about the Pythagorean theorem, can you now find the distance between the castle and the clown house? You would just use a squared plus b squared. And if I was to ask you what is how many units long is A, you would just count how many boxes it is, right? It's 1, 2, 3 units or squares or boxes or however you want to say it. But A would be equal to 3 and B would be equal to 2. So I can easily find distance when it's up and down side to side. And then with that information, I could then find my C. And that's what we're going to be doing in 7-4. Okay. All right. The other little, Jim says the marked yellow path shows the shortest path to the tent. So here's the path he's talking about. Is this the shortest distance between 2 points? Well, the shortest distance between 2 points is always a straight line. And we'll show mathematically here in a minute why the shortest distance would actually be the diagonal between the 2 points. Okay, so we'll get into that here in just a minute. All right, so go ahead and flip to example number 1. And they have put the castle and the clown house on a XY axis on a coordinate plane. And again, right, I'm going to take the shortest distance between the 2 points. Whoops, I want a pen. There we go. And I'm going to draw a straight line between the 2. And that's the distance I want to find, to go straight from one to the other. Well, again, to do that, I need to make a right triangle. And somebody asked last hour, and I thought it was a great question. Does it matter if I put the triangle up or down? It doesn't. You could put it here, That's a right triangle, or you could put it here. It does not really matter which way you do it. Okay, as long as you make a right triangle out of it. Now, how many units long is the leg that's going up and down? Or how many boxes is it? Jacob? 2. Good. What's the length of my other leg in units? Corbin? 3. Okay, those are easy because they go straight up and down or side to side, vertical or horizontal. With that information, now I can find the distance, the diagonal distance between those 2 points. And that's what they've done here. Okay, we're not going to rewrite it because it's already there for us. A squared, which is 2, plus B squared, which is 3, equals C squared, which that's what we're trying to find. So that is our hypotenuse right here that we're trying to find. And when they get all the way to the end, they get that the distance of the hypotenuse is 3.61 units. Now, I want you to be careful about something. This is a story problem. So story problems, you always want to think about your final answer as, is what I got as my answer, is that the final answer? And the answer is no here, and here's why. It tells us right here that on this little gridded map, 1 unit or one grid square equals a centimeter, and a centimeter equals 500 feet. So for every unit of measurement, it equals 500 feet. So what that means is that this length right here, the 2, really stands for 1,000 feet, right? And 3 really stands for 1,500 feet because 500, 500, and 500, 3 blocks of 500. So if I know that C is 3.61, I know that C equals 3.61 units, but I need to know how many feet it is. I would take that times 500. And that's where they get the final answer here of 1805. Okay, so while it is 3.61 units, it is 1805 feet. And did that prove out to what we talked about? 1,500 feet, 1,000 feet. If I was to walk the blue path, it would add up to 2,500 feet that I would walk in total. If I walk the diagonal or the red path, I would only walk 1,805 feet. The shortest distance between 2 points is always the diagonal, okay? All right, so there's that example. Now let's do this, try it. So we are going to connect point A and B because we want to know the distance between point A and B. So everybody do this. Connect point A and B. Now notice that's a diagonal, so we know we're going to have to use the Pythagorean theorem to find the distance. So we make a right triangle out of it, up or down, I don't care which, and state the distance between of the 2 legs. So Dayton, what is the distance of this leg right here? Or what is the unit measurement? How many boxes? How many boxes tall is this leg? 2. Okay, so we'd put the distance over here as 2. Okay, what is the distance of my bottom leg? Eli? 2. All right, so using the Pythagorean theorem, find out the distance between point A and B. Everybody work this real quick. A squared plus B squared equals C squared, and I just told you what A and B equals. A squared, which is 2 squared, plus the other leg. Everybody should have a calculator in their hand at the very end because I want you to round it to the 10th for me. Jace, you got it?
Yep.
Okay, give me just 1 second to get to that point, and then I can have you tell me the answer. And it's an estimate, so make sure you use the little squiggly equal sign. Okay, what'd you get, Jace? Round it to the 10th for me.
2.8.
2.8. Okay, everybody get 2.8? So C, right, or the hypotenuse, is 2.8. So you'd come over here. It is about 2.8 units. Okay, why do you need to use the Pythagorean theorem to find the distance between point A and point B? You don't need to write this. We've already said it. It's because you can't just count the blocks. Okay, it's diagonal because they're not horizontal or vertical of each other. They don't make straight vertical and horizontal lines. We have to use the Pythagorean theorem anytime it's a diagonal distance. All right, are we good with that one? All right, move on to the second one. Example number 2 is to find the perimeter of a figure. And here we're finding the perimeter of right triangles. What does it mean by perimeter? And I want everybody to circle the word perimeter. How do you find perimeter? Add up all the sides. That's what I want you to write above there. Add all side lengths. Okay, that is how you find perimeter. Think if you were going to measure the perimeter of my room, we would measure the front wall, the side wall, the back wall, and the window wall. We'd add all those up together, and that would give us the perimeter or the outside measurement of my classroom. Okay, so let's look at this triangle. Okay, we want to know the perimeter, but that means that we have to know perimeter, you have to know the distance of this. Are those too easy to find? What is the, let's see, Essie, what is the distance of the bottom line or the bottom horizontal line? 5, good. And who else haven't I heard from? Dalton, what's the distance of the up and down leg? 3. And notice this makes the right triangle. So that makes this the hypotenuse. Well, in order to know perimeter, we got to know the side lengths of all 3 sides. But because we know 2, we can always find the missing 3. And that's what they've done. Okay, again, I'm not going to work it again. And notice here, and I noticed it on your workbook homework, they do this too. Every once in a while, they'll put c squared equals. It's the same thing as if you had c squared over here. Why they flip it sometimes, I'm not really sure, but it doesn't change anything. Yeah, I have no idea. I think it's a typo. I think it's, honestly, what's it supposed to be? Can anybody tell? I think it's supposed to be 3 squared. That's a typo on the book. So what they've got is they've got your legs, which are 5 and 3. Okay, and you might want to change that because that looks a little confusing. So they've got 5 squared plus 3 squared. That's leg and leg. And that's where they get the 25 and the 9, add it together to get 34. They square root both sides. And here they get that the hypotenuse equals approximately, because it wasn't perfect, but it's 5.83. So now we know that over here, we can say that the C is 5.83. And with that information, to get perimeter, you would just simply add 5.3 and 5.83. And that's where they get that the perimeter of this is your final answer here, because it says it said find the perimeter. So the perimeter is 13.83. And they get it by adding the 5 and the 3 that was given, or that we figured out because we counted it, plus the hypotenuse, which we figured out using the Pythagorean theorem. Okay? If you have one that says try it, and I don't want to take the time to actually work it because I want you guys to have plenty of time to do your one question here today. If it asks you to find the perimeter and it just gives you points, what I would do, if it were me, I would grab a great piece of graph paper, or I would just sketch me out some graph paper. It doesn't have to be perfect. And I would just real quick, just in case you have one like this, and you guys don't have to do this with me right now. I would just really quickly, I would drop these points on real quick. So I would, and it doesn't have to be exact. Over 2, up 5. It doesn't have to be exact, right? Just label it whichever one you're calling that one. Over 5, down 1, that would be over here somewhere. And then 2, 1, 2, -1. So over 2, down -1. So now it's a nice, you can really see. You can see which ones make up the right angle. And then it gives you a good idea of what you're finding. Okay. And so you would just have to know on the x-axis, or on this one right here. Think about where your points were. You're at 5 right here. you're at 5 right here, and you go to 2. Well, the difference between 5 and 2 is 3. So the side length of that side would be 3. If you're going up and down, you went from the y of -1 all the way up to 5. So that's a climb of 6. So your side lengths would be 6 and 3. So I would just sketch it on a graph. I think it makes it so much easier than trying to figure out what the difference is in all those points without seeing it on a graph, because it's hard to see which ones are the legs until you actually see it on a graph. All right, so here's the deal for today. Here's your homework. And most of you, I think, will get it done in class. Number 7 on page 419, but notice I added a part B. Okay, you're going to do number 7. So you're going to fill in the units, the lengths of the two sides. You're going to find the distance of the hypotenuse. And then part B is you're going to find the perimeter. When you're done with that, come see me. You can either get 1 piece of candy or 2 mad dollars. If you don't get it done in class, it is due in tomorrow, and you need to show me tomorrow. All right? And you guys have about 5 minutes, so I'll quit talking. For those of you at home, when you get back to school, you need to show me problem 7, parts A and B. Email me if you have any questions.